Hi, ladies and gents. There are many things that have an effect on the rate at which a chemical reaction occurs. Now, when we talk about the rate of a chemical reaction, we're basically talking about how fast. Some chemical reactions occur very, very quickly, and some are very, very slow. An example of a very fast reaction you may have seen, and if you haven't done it, please try this at home because it's really fun. If you mix vinegar and baking soda, almost immediately they react. You get bubbles all over the place, you get carbon dioxide produced, and it is a fun reaction. It's really fun to do with your kids. Another example of a chemical reaction to not do at home, do not try this at home, is to burn flour. If you take something like flour and this individual is doing it as a demonstration, blowing this flour through the air and combusting it, it burns very quickly. And there have been some spectacular flour explosions through time that have been quite deadly and done a lot of property damage. But some chemical reactions are very, very slow. The decomposition of plant and animal matter that have produced the fossil fuels that we know of as oil and natural gas, that took millions and millions of years to occur. If you want a bonfire or you have a fireplace and you want a fire that's going to last throughout the evening or overnight, you put big logs on that fire and you let them burn, and they're going to burn very, very slowly and give you heat over a long period of time. So some reactions happen fast and some reactions happen slow. So what impacts or what things affect the rates of chemical reactions? Well, one of the things that has a big effect is concentration. The more particles that are present in a container, in a solution, whenever you have two chemicals you're mixing, the faster the reaction is going to occur. Keep in mind, a reaction, it requires the chemicals have to collide. You've got two molecules and they have to actually come in close enough proximity that they are going to hit each other and initiate this chemical reaction. So the more particles there are present, the faster the reaction is going to occur. Higher concentration means faster. So if you've got your chemicals all spread out, one over here and one way over here, there is very low chance that the chemicals are going to bump into each other. If you've got them packed tight like crowds at the Super Bowl, you are going to have a much better chance of a fast chemical reaction. Another thing that's going to impact the rate or the speed of a chemical reaction is pressure. And a classic example of this is a piston. If you've got gas molecules in an internal combustion engine and the molecules are a great distance apart, that doesn't mean they're necessarily going to combust. You might have everything you need there. You might have fuel, you might have oxygen, you might have everything you need to start that combustion. You might even have heat. But the reaction doesn't start until you get everything really, really close together. So you make them get very, very close together by putting them under pressure. And when they're very close together, by being plunged together under pressure in that piston, then you get more collisions and you get a faster reaction. For an analogy, if you've got a bunch of people sitting at a picnic and they're all spread out and they're sitting all over the grass, there's low chance they're going to bump into each other. You take that same group of people, you shove them into a very tight elevator, they're going to bump into each other because you've made them occupy a very small space. Another thing that's going to impact reaction rate is surface area. If you've got a chemical that is really tightly packed and only the outer edge of that chemical is going to react with all of the other things around it, the chemicals inside the middle is off limits. It doesn't have a chance to react with all of the chemicals that are surrounding it. So if you can increase that surface area, how do you increase surface area? Well, very often you can do that by crushing or mixing. And by crushing and mixing those chemicals, you can actually have a greater quantity of chemicals touching each other, and the reaction is going to occur faster. It's sort of like if you are running through a crowd and you're all balled up and so nothing's going to touch, you're not going to touch many people. If you're running through the crowd like this fellow with your arms spread wide, you're going to bump into more human beings. And last but not least, one of the other things affecting reaction rate is temperature. And as you know, temperature has to do with kinetic energy. More kinetic energy means more speed. And molecules that are going to be moving at a much faster rate of speed in the same amount of time, if you are going faster, you are going to be covering a bigger distance and you're going to bump into more people. So this fellow running through the crowd is going to have a bigger chance of running into more people than this sweet lady. She's probably going to be moving a tad slower and in the same amount of time not going to be bumping into as many people. So higher temperature means speed, and speed means faster, and faster means a higher rate at which the chemical reaction is going to occur. One last thing before we leave this, and what is the purpose that you own a refrigerator and a freezer? Well, the purpose you own a refrigerator, honestly, is to slow chemical reactions. That is the purpose of your refrigerator. It's also to keep beer and milk cold, but its primary purpose is to slow spoilage, and you do that by slowing the rate at which chemical reactions occur. See you later. Bye-bye.